Okay, I'm going to try to do now, we're going to look at cinematic camera motion. So something other than just following the player around mindlessly. It's going to kind of have a little bit of automation to it, a little bit of animation to it. So what do I mean by that? All right, well, in this first version, imagine I have my squirrel, and I don't want the camera just following the squirrel all the time. I want the camera to say, okay, if the squirrel has moved by a certain distance, then decide to move the camera. Okay, let's show you what that means. All right, so here's the squirrel, and if the squirrel decides to move more than 5 away from the current position, you'll see that the camera will sort of pop over to where the squirrel is. So we come back down, we'll kind of move, and again, is by kind of moves by these distance of 5, and let's see, we'll even do it so that if he jumps off the tree here, it will follow him down here, and he's going to hit an invisible object down here. If you look in our scene, you'll see he has actually hit a an edge collider down at the bottom, and that'd be something we probably want to trigger the death of or the end of the game. So we say, we kind of created this edge collider around here. That's sort of the edges of the world, and something like that. Anyway, that's just to keep him from falling off infinitely. But let's look at how do we create this motion, the camera motion, and maybe do something a little bit fancier than what I just showed with the camera motion. So I've created a Squirrel Camera script. So rather than put this directly inside the Squirrel controller, I have it as a separate script called Squirrel Camera. Okay, and let's look at that script. So right now in the script, all it really does is it has this update function, and in the update function, it looks at the distance, vector2.distance, between the camera's position and the current object's position, so the squirrel's position. It says, okay, what is the difference, the distance between those two things? It says, okay, if the distance is greater than 5, so if the squirrel has moved more than 5 meters away from the camera position, and the camera's just pointing straight down, it will decide, all right, I need to change the camera position to match the squirrel's position. Now, I don't just set one to the other because of this issue that the camera is actually positioned in 3D space, so the camera's Z position is important. I want to maintain the camera's Z position, but I want the camera to adopt the transform's X and Y position. So the moment that that distance is greater than 5, it says, okay, camera.main.transform.position, so the position of the camera, is set to a new vector3, which is made up of the player or the squirrel's position, X, squirrel's position, Y, and the camera's position, Z. Okay, I could tweak this now. I could say, all right, maybe the distance is going to be 6, or maybe it's going to be 10, something like that. Save it. Go over here, and we'll press play in the game. And now you'll see it's going to have to be much bigger, so a distance of like 10, and it's always going to recenter it so that the squirrel winds up at the center of the screen, right? A little bit odd when there's nothing else in the scene. So that's cool, at least it's following now, but it's not acting particularly cinematically. Okay, so to make it more cinematic, we want to start employing two of our favorite things, which are, of course, coroutines, smooth camera, we'll call this, yeah, smooth move. Right, coroutines. And what's the other thing we love? We love interpolation. We love lerping, right? So if we said vector 3 dot lerp, and we're going to interpolate from one vector to another vector over the course of time. So what we're going to do is we want to say the starting vector, vector 3, we need to starting, and ending. So we need two vector 3's, the starting point and the ending point, and we're going to interpolate from starting to ending over the course of t. All right. Now, so let's say here the starting point is going to be, let's grab this here, and we will say starting equals our current camera position, actually, camera.main.transpose dot, transform dot position. That's our starting position. And our ending position should be what? Equals that. Okay. So the ending position is going to be the squirrel's position, X and Y, and the camera's position, Z. Okay. So I could have even said starting Z. That works. Right? All right, so we want to get from here, from starting to ending over the course of t. So we will also say float t equals 0 for starters. Now, here's the magic. In our interpolation here, so we're going to say we want to interpolate over the course of some time. So we're going to say while t is less than what? Or maybe we'll say even, we'll do this for int, no, t equals 0 to t less than, we're going to move in 2 seconds. And we're going to move at a rate of t plus equals, say, a 20th of a second, which is pretty reasonable for an animation. A 20th of a second is 0.05. Okay. And, all right. So we could say from t equals 0 to t is less than 2, move or increment our 0.05, and we're going to use t here. Now remember that since it's 2 seconds, we want to divide by 2. All right, or we could have even done this. If we don't want to do the divide by 2 there, we could say, well, okay, t is less than 1, but in order to do that, we're going to have to change our rate here. So we would change our rate to be 50 hertz, right? Or we only increment this by 0.05, 0.25, right? So now it's going to be the same number of intervals, but now we need to have a weight in there, right? We do have to say return yield new, return, or what did I say? Yield return new wait for seconds, and we're going to wait for what? 0.025 seconds. Okay, so we're going to wait for a 50th or 40th of a second. Wait, how many of those? 0.025. Yeah, that's going to be a tiny slice of a second. Wait for that amount of time, increment, and hopefully eventually wind up at t there. Now, what we're going to do, of course, what we want to have happen here is that has to be the new camera's position. So we have to say camera.main.transform.position equals that new vector, right? So this part in here now is not what we want anymore. So what we should do here is we're going to say start coroutine smooth move. Okay, so the moment that the camera and the squirrel are greater than 10 apart, it will go ahead and start this coroutine, right? Now, one other thing I want to be careful of here is I don't want this to trigger itself over and over and over again, right? So I need some kind of flag. Here's what I'm going to do is I'm going to say Boolean. This is going to be sort of a semaphore. In camera move equals false. All right. Bool. There we go. Bool in camera move is false. So what I want to do is say here, if not in camera move, then it's okay to start this. Okay. Right? It's okay to do this. If I am in a camera move, I don't want to do that. So what I'm going to do here is I'm going to say in camera move equals true. So that's going to say, okay, you started smooth move. And here is where I'm going to say in camera move equals false. So I'm kind of wrapping this in this, what we call a semaphore, kind of signaling to say, all right, make sure you don't re-trigger this smooth move if you're already there. If you're already in the process of moving, don't try to move again. All right? Let's see if that worked. See if my logic is sound here. All right. And so there we go. The player has moved the mouse, the squirrel. You can see, and it falls, and she gets to the bottom. Much more cinematic, right? Now, it doesn't always wind up centering him because it can't assume a new position while it's in that smooth move there, right? So I could do something where I get much more elaborate and say, well, okay, if it's not centered or something like that, that would be something to do. But for now, we'll leave it just like that. All right, so this is triggered based on a distance here. What if I wanted to do it triggered on some sort of collision? Okay, that would be another thing to do. And I could say, let's put something in the scene. So we'll say, third-party assets here. Sunnyland Woods, props, environment maybe. Let's see, I want to be miscellaneous. Okay, here's an acorn. And I'll put this acorn in the scene and change its import settings to, it's going to be really big. Apply. So we've got this acorn over here. And I'm going to move the acorn down a little bit here. It's going to be right there. Maybe right here. And I will add a component to that called acorn trigger. Yep, create and add. And let's see. So other things I need on this object is I will need a collider, and it will be a let's see, a capsule collider 2D, say, for example. Edit collider. Where is it? Okay. tighten it up a little bit here. I don't know. And it will be a trigger. Okay. And we'll go in our acorn trigger and say, get rid of all this stuff. And we will say on trigger enter 2D. And we'll make it just really, really simple. We will say, if that touches, let's look at our Squirrel Camera here. And we're going to do something similar. We're going to do this. We're going to have a smooth move for the acorn trigger. All right. And notice I can do all this same stuff. Bool in camera move equals false. Now this would be another interesting application, potentially, of a some inheritance, right? Because now I'm using this code over again, so maybe I should be doing that. Who knows? Okay, I'll leave that for another demonstration. So we have now in our acorn trigger, we're going to do that, but it's going to be in reaction to this on trigger enter 2D instead of the if distance and so on. All right. So let's go back. Whoops. Let's go back to acorn trigger and do this. We're going to say start that coroutine smooth move if we're not already in a camera move, in this local camera move, based on triggering, based on touching that that acorn. So let's save. Whoops. Let's see. I don't want to do that. Control Z. Save. Let's give that a try. Whoops. All right. So what should happen if I touch that? Oh, I know why. Because it is not on. Let's see. Let's make this put it on the enemy layer just so that the collision can happen, right? Because we disallowed collisions for the default layer. So let's see here. I want to move. All right. And if I touch there, it centers where the acorn was. All right, so even if I did this, let's see, let's do this. Let's say main camera, and I will move the main camera here, just for the sake of argument. And I will, no. So you see, anytime I touch that acorn, it will recenter the camera on the acorn. And it's doing it over the course of, in this case, 2 seconds. Why is it 2 seconds? Well, it's because I am, in each increment here, I am going from, I'm incrementing by that amount. So it's a tiny, tiny slice of a second. Does it might be so that's 1 second. Wait for that. Oh no, I guess I am. Yeah, I'm still waiting. That's 1 second. It's just much smoother than that. If I wanted it to be 2 seconds, I would have left that at 0.05. That would have been the obvious thing to do. A little bit chunkier there. That wasn't. I might have had two. You have to be a little bit careful. You can wind up having camera moves that are going to fight each other too, and that would be weird. So this might be a good case to have a class that is a static class, so you don't wind up being in two camera moves at the same time. So we'll leave that for a more advanced exercise. So don't get too carried away with the number of camera moves. Otherwise, you're going to have them potentially fighting one another. But for now, I think this works reasonably well. Okay. Another good tutorial lesson to try things out. Good luck.